The first concept is isomerism. So in general, isomerism means, okay, in generally, isomerism means, okay, here isomerism represents same molecular formula, right, but differ by the physical and chemical properties of the compounds. The compounds which are having the same molecular formula but differ by physical and chemical properties, those are called here isomers. That phenomenon is called here isomerism, right? The compounds which are having same molecular formula, but differ by physical and chemical properties. Are called isomers. The phenomenon is called isomerism, right? The phenomenon is called isomerism. So this is the isomerism. These are called isomers. So generally, let us consider a example. So the general example here, one is the C2H6O. So this one is the chemical formula, right? This one is the chemical formula. So this chemical formula of the compound, so it has the two isomers, right? It has two isomers. So based on that reason here, so one is CH3 CH2OH, another one is CH3O CH3. Just observe here what happens. CH3 CH2OH, the molecular formula of this alcohol is C2H6O, C2H6O. Same like ether also. This is the another functional group is present in this compound. This one is the alcohol functional group is present in the given compound, C2H6O. The molecular formula is same, but these functional groups are different here. That means the alcohol properties are different. Here ether properties are different. So based on that here, so what are the properties here? Physical properties. Just generally I am explaining. CH3 CH2OH is a ethyl alcohol. So it is a liquid, right? It is a liquid at room temperature, right? At room temperature it is liquid. The boiling point of this alcohol is 78 degrees centigrade temperature, right? At that temperature only this alcohol boils. Then same, if you observe in the second compound ethers. So here also the physical properties, it is a gas at room temperature, right? At room temperature ethers are the gases. Then next here the boiling point is minus 24 degrees centigrade temperature. So these two physical properties, if you observe in these two cases, these are the different physical properties or not. So this is about the different physical properties. Next, observe in the chemical properties. Okay, in the chemical properties. So what are the differences here? So if it is reaction with HI, for example, right? When HI treatment with the alcohol, so this one convert into ethyl iodide, right? CH3, CH2, OH reaction with HI in the presence of heat. So what happens? This one convert into ethyl iodide, right? It is converted into ethyl iodide plus water, right? It produce ethyl iodide plus water produced when the alcohol reaction with the HI. If you observe in the ether molecules, CH3, OCH3, when it is reaction with the hydrogen iodide in the presence of heat, this one convert into only ethyl iodide formations, right? Only ethyl iodides. Only ethyl iodide formation. Just next, another property, just generally I am explaining here also. When alcohol is reaction with the highly reactive metal of the sodium. When alcohol reaction with sodium here, sodium, this one evolves the hydrogen gas, right? When it is evolves hydrogen gas. But in this case, if you observe, there is no hydrogen gas is evolves, right? There is no hydrogen gas is evolved. There is no reaction, right? There is no reaction with the sodium. Okay. In this case, these are the, if you observe in this case, okay, what are the observations here? Same molecular formula of this compound has the two isomers. One is the alcohol, another one is the ether. So this one, the properties at room temperature only, this one existing in the liquid state, that one existing in the gaseous state. So boiling points also differ. These are the physical properties. If you observe in the chemical properties, this one produce ethyl iodide with water molecule, but in that case, this one produce only ethyl iodide. Then next, in the next second case, hydrogen gas is evolves, but in this case, there is no hydrogen gas, means there is no reaction taking place. So these are the general information about the isomerism. So why should we learn isomerism means? So general explanation only. So these are the two kinds of compounds, right? But both are the isomers, right? Based on that, so this isomerism is classified into two types, right? Next here, classification of isomerism. So one is structural isomerism, another one is the stereoisomerism. Again, structural isomerism classified into 6 types. So what are the classifications? Okay, right here. Classification of isomerism. Right. So first here, okay, first isomerism classified into 2 categories. One is the structural isomerism, another one is the stereoisomerism. Right, these are the 2 classifications. The next, again the structural isomerism classified into 6 types. So in these, one is chain isomerism. Next, another one is positional isomerism. Next one, functional. Third one is functional isomerism. Next, fourth one is the metamers. Fifth one is ring chain isomerism. Sixth one is the tautomers or tautomerism, right? So these are the 6 classifications. Structural isomerism is classified into 6 categories. The next stereoisomerism is again classified into 2 categories. One is the conformational, another one is the configurational. Right, one is the conformational, another one is the configurational. So these are the 2 classifications. So next, again, this configurational isomerism is classified into again 2 categories. One is geometrical. One is the geometrical isomerism, or it is also called as a cis-trans isomerism. Okay, cis-trans isomerism. The next another one is the optical isomerism. Optical isomerism. So this is about the classification of the isomerism. So based on that isomerism here, structural isomerism. So it is based on the connectivity of the atoms or the groups, right? The compounds which are having the same molecular formula but differ by the connectivity of the atoms, right? Connectivity of the atom. So here also those all are the physical and chemical properties also differ, but the connectivity of the atoms are the groups. Based on that, these are classified into 6 categories: chain isomerism, positional isomerism, functional isomerism, metamerism, that is called here metamerism. So ring chain isomerism and the tautomerism. So these are the 6 classifications. Then next here, stereoisomerism. So stereoisomerism means the compounds which are having the same molecular formula but differ by that bond connectivity in the space arrangement only. Okay, the arrangement of the atoms or groups in space. So because of that reason, these are classified into 2 categories. One is a conformational isomerism, another one is a configurational isomerism. So in the conformational isomerism, so these are the rotations taking place. Okay, bond rotations are taking place. But if you observe in this case, this configurational is bond rotation is restricted. That means restricted double bond rotation taking place in the configurational isomerism. So based on that, again these are classified into geometrical isomerism and optical isomerism. So I will explain clearly each and every part. So first one is the structural isomerism. Okay. Let us discuss about the structural isomerism. So these structural isomerism classifications. So structural isomerism means molecular formula is same but differ by the connectivity of the groups and the atoms. Okay. In this first one is chain isomerism. Chain isomerism. Okay. First one is structural isomerism. In this structural isomerism, so these are having same molecular formula but differ by connectivity of atoms or groups, right? So based on this, these structural isomers are classified into 6 classifications. So in these, the first one is chain isomerism, right? First one is chain isomerism. So this chain isomerism arises due to the difference in between the chain, okay, difference in between the arrangement of chain, okay, chain isomerism arises due to difference in arrangement of chain. So those are called here chain isomers. The phenomenon or the process is called the chain isomerism. So based on that chain isomerism, so what are the essential conditions, right? What are the essential conditions to explain the chain isomerism? So here, what are the essential conditions here? So I am writing here, what are the essential conditions? Right, essential conditions for the chain isomerism, right? The nature of the functional group and the locands must remain same, right? There is no change in that. What is that first point here? The nature of the functional group and the locand must remain same. That is the first condition for the chain isomerism. Then next, what is the second condition here? So after that, the main chain of the compound or the side chain or both must be changed. Okay, this is the second condition for the chain isomerism. So these are chain isomers found in the compounds containing at least 3 carbon atoms, right? So more than the 3, right? More than the 3 carbon atoms. So these are the essential conditions for the chain isomerism. So the first condition is the nature of functional groups, the nature of functional group and locands must remain same. So this is the first condition. The next second condition. So what is that here? Second condition means based on this nature of functional group and locands, these are remain same in the given parental chain. The next second one is the main chain or side chain or both must be changed. Okay, both are must be changed only. So here, what is the third point here? The essential condition of the chain isomerism. So it is found in compounds containing more than 3 carbon atoms. So that time only we observed or we found in chain isomerism in the given compounds. So what are the examples for the chain isomers, right? Next I want to explain the examples for the chain isomerism. So listen carefully here. So what are the examples? How to identify the chain isomers in the given compounds? So molecular formula is same here also, right? That molecular formulas are same, right? So examples. So the first one is pentane, right? So pentane is a one compound. So pentane has, it has 5 carbon atoms. It has 5 carbon atoms. Pentane represent 5 carbon atoms are present in the given compound. So according to these essential conditions, it is found in the compounds containing more than 3 carbon atoms. So it has 5 carbon atoms. So this one exhibit the chain isomerism. So because of that reason, so I am writing the bond line structure of the pentane. It has the 5 carbon atoms in the given chain. 1, 2, 3, 4. This one is 5, right? This is the normal pentane, right? This one is normal pentane. Next, right? So what happens here compared to the first compound? So the second compound containing 1, 2, 3, 4. So what is the difference in between them here? So 1, 2, 3, 4, 5. So how many carbon atoms are present in the main chain, right? Main chain containing, conditions I am writing, main chain containing or contains how many carbon atoms? 1, 2, 3, 4, 5. 5 carbon atoms. Next, there is no side chains. Side chains equal to 0, right? This is for first compound. Next, another compound. Here main chain contains, that means main chain contains 1, 2, 3, 4 carbon atoms, right? These are the 4 carbon atoms. The next, if you observe in this, so this one is considered as a main chain. So this compound is automatically a substituent, right? Or it is also nothing but a side chain. This one is nothing but side chain. So how many side chains are contains here? Only one, and the side chain contains only one carbon atom, right? Only one carbon atom. So based on these essential conditions, so this second condition is also satisfied here. So the main chain or the side chain are both or must be changed. So in the first one, the main chain contains 5 carbon atoms, but in this it has 4. Next, so there is no side chains are present, means 0 side chains are present here. Here one side chain is present on the given compound. So these two are belongs to chain isomers, right? Chain isomers. The next here, so this is the another isomer of the pentane, N-pentane. So what is the name of this one? So the second carbon contains one methyl group. The name of this compound is 2-methyl. So the parental chain containing here 4 carbon atoms. So 4 represents here, the root word is but. All of the single bonds present butane, right? So 2-methyl butane is the name of this compound, and this is the normal pentane. Next, if you observe in this case, so this is the bond line structure. It has 1, 2, 3. The main chain containing here 3 carbon atoms. Main chain contains 3 carbon atoms. Next, side chains. How many side chains are present in this? This is the one side chain. This is the another side chain. So totally 2 carbons. So the side chain containing 2 carbon atoms. So what is the name of this compound? At the second portion, it has the 2 substituents, 2,2 dimethyl. Okay, 2,2 dimethyl propane. So the main chain containing 3, the root word is pro, all are single bonds, propane. Here this di represents primary prefix name. If 2 same kind of substituents or the simple substituents are present on the second portion, that one represented by di. So the name of this compound 2,2 dimethyl propane. So now N-pentane, 2-methyl-butane, and the 2,2 dimethyl propane. So these all are the examples of the chain isomers, right? This process is called only chain isomerism. So this one has a different properties, this one also has different, this one also has different properties. So based on that reason, these all are the examples of the chain isomers. Okay, so let us take another example. Right, next example, I want to explain another example here. So already I have just now I have given one condition, that is the nature of the functional group and the locates must remain same. So must remain same means there is no change in the functional group. There is no change in the functional group only. So what is the second example here I am taking? Right, the example is, okay, this one has the 5 carbon atoms in the given chain. So it has like this, right? Next I am taking same like the next, it has Cn. Okay, just observe it. So the Cn is the functional group present on the given carbon chain. If you observe in this case, here also one Cn group is present. So I am giving the numbering here. This is the functional group 1, 2, 3, 4, 5 and 6, right? The chain containing 6 carbon atoms. Next, if you observe in the second compound, I am giving from the main functional group only. So this is a 1, 2, 3 and 4, right? So this one is nothing but it is a side chain, right? This one is side chain, right? Here there is no side chain is present, right? Here there is no side chain is present. So based on that, first observe the functional group in the first compound. The functional group of cyanide group or this is also called as the nitrile, alkyl nitrile. So nitrile functional group is present in the both conditions. Functional group is same according to the essential condition. First essential condition, so the nature of the functional group is must remain same, right? Here there is no change. Same functional group Cn, here also Cn. There is no change in the functional group. But which one is changed? Right. Here the main chain contains 6 carbon atoms, right? So there is no side chains. Side chains are 0. Okay, side chains are 0. The next, in the second case, how many carbon atoms are present in the main chain? So this one is the main functional group. It has here totally 4 carbon atoms in the main chain, right? Your main chain contains 4 carbon atoms, right? So how many side chain here? Only one side chain, but that side chain contains 2 carbon atoms, right? Ethyl group is the side chain. So here 2 carbon atoms. So according to that essential conditions, here there is no change in the functional group. This one is same, it must remain same. But the remaining here main chain and the side chains are different. So because of that reason, this one is belongs to chain isomer, right? These two are the belongs to chain isomers. The next here, another example, I want to discuss with you another example, right? Okay, just I'm giving like this, okay? And one more example. So here 1, 2, 3, 4, 5, 6 carbon atoms. 1, 2, 3, 4, 5, and here also it has 6 carbon atoms, right? So why I am explaining here this compound example, just observe here. According to the essential conditions, this one has 1, 2, 3, 4. Okay, 1, 2, 3, 4. So the main chain containing 4 carbon atoms. So one side chain containing 2 carbon atoms, right? In this case, it has same 6 carbon atoms. There is no side chains. All are the 6 carbon atoms only present. 1, 2, 3, 4, 5, 6. So main chain contains 6 carbon atoms. So chain is differ. Here there is no side chain is present, but in this case it has one ring structure, but the ring structure containing one double bond. In this case triple bond is present. Here a double bond and the triple bond both are the different functional groups. So according to our essential conditions, the functional groups must remain same. So in this case these two are the not a chain isomers. Okay, these two are the not a chain isomers. So these are the very important, the identification of the chain isomers. Okay, thank you.